Hello, welcome back. Here is Ali Talabi, and this is our review session for Module 11. So let's start our session. In this module, we'll learn about the risk and return. So we talk about both sides of investment. So the return, we call that kind of the visible half. The risk is the kind of the hidden half, which is not that clear unless you have some data to measure, calculate your risk. So we learned that we can use several methods to calculate the return. So we talk about the arithmetic, we talk about geometric return, and I mentioned that the geometric average return is providing a more realistic return based on the average compound return per year. So if you're more concerned about the growth of your money, so geometric is providing you a better approach. However, if you're talking about several withdrawal or depositing your money in several stages. In other words, if you're looking for the multi-period return, neither arithmetic nor geometric are appropriate. So in this case, it's better to use the dollar-weighted average return, which is actually using the IRR to calculate the return. So we talk about the risk as well, and we mentioned that the risk is showing how far you are from the expected return. Now, we mentioned that if you're using the standard deviation or variance to measure the risk, one of the major issues is those measurements are actually including both the downside and the upside as a part of the risk. So they don't care you are earning more than what you expect or you're earning less than what you expect. Both deviations are type of risk. So in this case, we mentioned VAR or value at risk is a kind of better approach because it just focuses on the downside risk. It considers the worst case scenario and it actually uses the normal distribution to tell you with the worst case scenario and what probability exists in terms of losing a specific amount of money. And we also learned from the historical performance of the capital markets that the risk and return are moving on the same direction. So if you're asking for the higher return, so that's kind of reasonable to expect to take more risk. If you're using the variance or standard deviation, so it's better to combine them with the return. So how you can combine them is by using the CV or coefficient of variation, which captures the effect of expected return and risk. And higher CV, it means that for each specific unit of return, you are actually taking higher risk. Now, let's look at the questions. So let's look at the first question. Here we have information regarding the returns for the last 4 years. Our goal here is to find the arithmetic average returns and geometric returns. So we learned to calculate the arithmetic return. We are simply required to add all these returns and divide them by 4. So in other words, I'm just adding 15% plus minus 10% plus 25% plus 5%. And then divide them by 4. By this, I will get 8.75%, which is my arithmetic average return. What about the geometric? For the geometric, you need to actually add 1 to all of these returns. So it should be 1 plus 15, which is 1.15%. And you need to multiply them times 1 plus minus 10% is 0.9 times 1 plus 25% is 1.25 times 1 plus 5% is 1.05. So that's actually the first step, and then you need to find the force root of this number. Why force? Because we're talking about 4 periods, so it should be 1 over 4 minus 1. So that's how we calculate the geometry average return. So this gives you 7.96%. As we argued before, always geometric average return provides you a lower return than the arithmetic average return. So 7.96, that's a geometric average return. 8.75 is your arithmetic. So which one is more relevant? Usually geometric is more relevant average return because it considers the compound factor and the growth of your investment. Now let's look at the next question. Let's look at the next question. Question 2. We have three stocks here, and we are going to choose which stock we are going to invest on, stocks A, B, and C. So they have different expected returns and different variance. So we learn to capture the effect of both risk and return. It's better to use a measurement which we call CV, or coefficient of variance. The CV is based on the standard deviation and the expected return of our investment. So, and for sure, we're looking for lower CV because it indicates that per unit of return, how much risk you expect to actually take. Here we don't have the standard deviation, just we have the variance. So what is our job here? Our job here is to find the square root of the variance first, and then we can calculate the CV. So let's calculate the standard deviation first, and then we'll talk about CV. So here I calculated the standard deviation. So as I mentioned, that's the square root of the variance. So based on the standard deviation, now I can find the CV. So I just divided the SD by expected return to find the CV for assets A, B, and C. So if you look at the CVs, you see that A and C actually have the same CV too. However, B is showing the lowest CV amongst these three investments. So what does it mean? It means for stock B, for each unit of return, I'm just taking 0.4 unit of risk. So I should take a stock B and invest on that because it gives me the highest return for the given risk or the lowest risk for the given return. So the answer should be just stock B. Let's look at the next question. Question 3, we have the expected return of 10%, and we have the standard deviation of 5% for the stock XYZ. Now, based on this, and based on the argument that we assume that's a normal distribution, which statement is correct? So in this question, we are using actually var, or value at risk, to find the kind of the worst case scenario, the best case scenario. Now, let's refer to what we had before and summarize the information we have in this question. So, as we discussed, the expected return is 10%, the standard deviation is 5%. And we know, remember from the normal distribution, that 68% of data are within one standard deviation of average return. So 68% probability that my return falls between 10% minus 5 and 10% plus 5%. In other words, there is a 68% probability that my return is between 5% and 15%. What about the rest? The 32% chance will be that my return is either greater than 15% or my return is less than 5%. And that's the A actually. And A, we also mentioned that there is a this is a 32% probability for both. And A was saying there's almost 15% chance that you won't earn more than 5%. And remember, this is normal distribution, so 32% is almost 60% on the left side and 16% on the right side. So that's the correct statement to say there is almost 15% chance that you won't earn more than 5%. So this is referring to this part. So it's almost 15% here, 15% here. So statement A is correct. Also, we can say 95% of data within 2 standard deviation of average return. So in other words, you can say there is a 95% chance that your return is between 0 to 20%. So it doesn't answer, it doesn't kind of, it doesn't reflect any of the statements we had before. 99% of data within 3 standard deviation of average return. In other words, there is a 90% chance that my return falls between minus 5% and 25%. In other words, there's almost 1% chance that my return is either less than minus 5% or greater than 25%. In other words, there is a very low chance, maybe almost 0.5%, that my return is less than minus 5%, or I will lose more than 5%. And that's a statement C. Statement C was saying that there is less than 1% chance that you will lose more than 5%. So in conclusion, we can say both statements A and C are correct based on this var argument. That's it for today. Thank you very much. Have a wonderful day. Talk to you soon. Here is Ali Talabi. Take care and stay safe.